Hello dear friends, welcome my channels. Today's discussion is complex analysis. So friends, my first question is question problem solution. Find the roots of the equation z to the power 4 minus z square minus 2z plus 2 equals to 0. So friends, let's start solution. Since by fundamental theorem of algebra, every polynomial equation pz equals to 0 has at least one root. So friends, now pz equals to z to the power 4 minus z square minus 2z plus 2 equals to 0. So has at least one root. So friends, has at least one root means we can get one root in here. So you can see that if z equals to 1, then p1 equals to 1 minus 1 minus 2 plus 2 equals to 0. So let's cut this, and after that we get it is 0. So friends, we can write pz equals to z minus 1 into qj. And friends, after that equals to, we can write equals to 0. So where qz is a polynomial, where qz is polynomial of degree 3. So friends, qz can be written this way: qz equals to z to the power 4 minus z square minus 2z plus 2 divided by z minus 1 equals to, we get z cube plus z square minus 2. Now q1 equals to 1 cube plus 1 square minus 2, so it is 0. So I can write qz equals to z minus 1 into rz, and I can write rz equals to z cube divided by z minus 1 equals to z square plus 2z plus 2. Now rz equals to z square plus 2z plus 2 equals to 0. And so friends, it can be written 1 equals to minus 1 is equal to plus minus I. So friends, we get z equals to 1 minus 1 plus minus I. So friends, now we will go to solve this problem questions based. This is the very good questions. I think that this is the questions number 2. So friends, you see that this is the complex residue problem, where C is the close bounded sin pi z square plus cos pi z square z minus 1 whole square divided by z minus 2 dz, where C is the equals to 3. So friends, given that equals to sin pi plus cos pi z square divided by z minus 1 whole square z minus 2 is analytic. Analytic within the circle mod z equals to 3, except at the poles z equals to 1 and z equals to. So friends, note, this is one note I write. This note is very important. If the function fz has a pole of order m greater than 1 at the point z equals to a, then residue f a equals to 1 by m minus 1 factorial limit z tends d m minus 1 dj dm minus dj dm minus 1 z minus a whole to the power m fz. This is the formula. So friends, I hope I can clear this formula. Now I apply this formula. For this integral. So friends, hence residue f2 sorry, not f2, I want to find out 1. F1 1 factorial ddz z minus 1 whole square fz. So friends, this is the formula. I apply this formula, friends. This is my formula, friends. This formula I use. What is the formula? Formula is 1 minus 1 whole for 1 factorial z minus z tends to a and dm minus 1 dz zm minus 1 and z minus a whole to the power n fz. So friends, here m is equal to 2 and e is equal to 1 friends. So it is easily clear for everyone. I hope it is clear for everyone. So so whatever I get friends, ddz calculation is, it's lengthy, but sine pi z square plus cos pi z square divide by z minus 2. So friends, what is the formula now? Next I apply this formula, ddx of u by v. This formula, noted that this formula is very easy, that this formula is divide by v square v into du by dx minus u into dv by dx friends. I apply this formula friends. Now whatever I get z minus 2 whole square and sine pi z square and z minus 2 is in here because the v portion and u is this, so I have to derivative, and 2 pi z cos pi z square minus 2 pi z sine pi z square. This is the first portion, and second portion is minus z minus 2, derivative of z minus 2 is equal to 1, so I get sine pi z square minus cos pi z square. This is the total formula friends. I hope I can clear this formula. This formula is very simple. Now I have to putting in here limit z tends to 1, and in here also limit z tends to 1. So friends, just putting this value 1 minus 2 is equal to 1 minus 1, and cos pi, what is the value of the cos pi friends? Cos pi is equal to minus 1 and z equals to 1, so friends I get minus 2, and sine pi is equal to 0, so I don't need to write this, and 2 pi I write in here 2 pi, and also there is a pi z square means 0, and cos pi is equal to minus 1, so I write minus into minus 1 divide by 1 minus 2 whole square. So whatever I get friends, I get this value is 2 pi and residue f2 limit z tends to 2 z minus 2 into fj. That value is, this value is, it can be written limit z tends to 2 sine plus cos pi z square divide by z minus 1 whole square. This value is equivalent to just putting in here also 2, sine 4 pi means 0, cos 4 pi is equal to 1, so this value is 1. So friends, integration closed integral c sine pi z square plus cos pi z square divide by z minus 1 whole square into z minus 2 dz is equal to 2 pi I residue of f1 plus residue of f2 by Cauchy's theorem. By Cauchy residue theorem. So friends, whatever I get integration c into fz. So friends, just putting the value of just putting this value f1 residue f2. So whatever I get this value is equals to 2 pi I, and this value is f2 is equal to 1 and this value is 2 pi plus 1. So I mark it 2 pi plus 1 is equal to 2 pi I into 2 pi plus 2 is equal to 4 pi I into pi plus 1. So friends, let's start to discuss another problem. Question number 3. If G is a region and f such that G tends to C is an analytic function such that there is a belongs to G with mod of fa greater than equals to mod of fz, for all z belongs to G, then fz is constant. So friends, start our solution. We have to prove that fz is constant. So friends, it is Liouville theorem. So let there is a closed ball b bar a comma r. This is a ball where a is a center and r is a radius. This is the closed ball. It belongs to G. And gamma t equals to a plus r to the power e to the power I t for 0 greater than equals to t equals to 2 pi. Then we have fa 1 divided by 2 pi I integration closed integration fw divided by w minus a dw equals to 1 by 2 pi divide integration 0 to 2 pi f a plus r into e to the power I t, and mod of f a, that implies mod of f a greater than equals to 1 by 2 pi 0 to 2 pi mod of f a plus r into e to the power it dt greater than equals to mod of f a. Since mod of f a plus e to the power t r less than equals to mod of f a for all t. So friends, how we can get this value? Because we discuss in here mod of fz, this is the mod of fa always greater than equals to fz, because where z equals to any number, z equals to I take a plus r e to the power it for all t. That implies 0 to 2 pi fa mod of fa minus mod of a plus e to the power it r mod dt equals to 0. Since integrand is non-negative, since integrand is non-negative, hence we have mod of fa mod of a equals to mod of f a plus r e to the power I for all t. Moreover, since r is arbitrary, we have f maps any b a comma capital R subset of capital G into circle mod of Z equals to mod of alpha, where f a is equal to alpha. This implies circle, this implies f is constant on d comma capital. In particular, fz equals to alpha for mod of z minus alpha less than capital R, that is fz equals to constant. So friends, I stop my work now, and thanks for watching friends.